All right, here's a quick video on vectors, and we're looking at this time relative magnitude and direction, and we'll also look at estimating magnitude. So let's first start with looking at relative magnitude and direction. So we're going to compare vectors. All right, so here's our first example. Given two vectors, compare their magnitude and direction. So on this one, we need to notice that this vector here is really the same length, therefore the same magnitude as the other vector. So the magnitude is the same. And then the direction, they're both pointed exactly the same direction. Therefore, the direction's the same. Okay. Now, the next one is now two vectors. This time, those vectors are going the same direction. As you can see, they're both pointing the same direction. So we can mark here as the same. And the magnitude is different. They're different lengths, and so the magnitude is different. That's really all that we're asking to do for this first section, is just compare the different vectors. So let's just look at a few more. This example, as you can see, they're both the same length, and they're going in opposite directions. And so as we write this down, the magnitude is the same because they're the same length, and the direction is different. Okay, we have another one. Now this time you see the magnitude is different, and the direction is different. Okay. And then finally, for my examples, we'll notice that these two arrows are the same length. And so because they're the same length, the magnitude is the same. And the direction is different. Okay, now when you work on the homework, it'll be something similar to that. All right, now let's do the next one. This part is estimating vectors. And we're working about estimating the magnitude of vectors. The first part is to type the component. So we need to count from the initial point. We're going to count, I'm going to first count in the x direction. 1, 2, 3, 4, 5, 6, 7. So that's 7 positive direction. And then we're going to go from here down 7. So that's -7 here. So our component form is x is first. So we do 7. And y is second, -7, like this. Now the next step is going to be to, my dog wants to play. Okay, the next step, I've got these written here, so let's go ahead and get rid of my writing. There we go. And this time, what we're going to do is use tools that we have, a sheet of paper. And you see like this Post-it card that I've done here, I've put little hash marks in line with the grid. Now we're asking for generalities. This estimate, there is no inches or centimeters or whatnot, but we do know units. Each square here is a unit. So I put a mark on the paper. And then the next thing that I do is turn the paper so that it's lined up with the vector. And then I'm going to count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, almost, but not quite 10. And because it didn't quite make it there, notice that it says estimate to the nearest 1 decimal place. So I could do either, and either will work for the purposes here. I could call this like a 9.9, or I could call it a 9.8. Because we're doing 1 decimal place, we'll do, because we're looking for approximations here, we're looking for a plus or minus 1/10. So that's just getting within that distance. You'll notice it doesn't quite make it to 10, and that's important to understand as you're working through this. Now your task is to do that on your 3 problems on the homework. And if you have questions on the other part, please see the video on point slope form. Thank you.